Find the general term a sub n for the geometric sequence with the given terms. We have a sub 2 is equal to 48, and a sub 6 is equal to 62,208. So if we recall, the general term for a geometric sequence is a sub n is equal to a sub 1 by r to the n minus 1. So now notice, when n equals 2, right? When n equals 2, a sub n is 48. So then what we can write here is 48 is equal to a sub 1 by r to the 2 minus 1. Similarly, for the other ordered pair, we could write, all right, so when n equals 6, a sub n is 62,208. So we could write 62,208 is equal to r by, is equal to a sub 1 by r to the 6 minus 1. And so we need to solve for the a sub 1 and the r. And you might have learned how to do something similar to this back when you were studying exponential functions. So what we're going to do is we're going to use division. So I'm going to take the 62,208 is equal to a sub 1 by r to the 6. So 6 minus 1 is 5. I'm going to take 48 equals a sub 1 by r to the first. And I'm going to divide those left-hand sides and right-hand sides. So let's see, 62,208 divided by 48 is 1,296. A sub 1 divided by a sub 1 is 1. So those reduce out. And I have r to the 5th divided by r to the 1st, and so that's r to the 4th. So we now have a power equation, and we've learned to solve them by using exponents. So I raise both sides of this equation now to the 1/4 power. So 1,296, raise that, and be careful about when you raise it to a fractional power, you need to put that in parentheses. 1,296 to the 1/4 power is 6, and so 6 is equal to r. So now 6 is equal to r, so now take one of those two equations and let r equal 6, and you can solve for a sub 1. Well, the easier equation to use would be this one, the second equation. 48 is equal to a sub 1 by 6 to the first power. Well, 6 to the first power is just 6. Dividing through by 6. We find that a sub 1 is equal to 8. So we have r equals 6, a equals 8, so then a sub n would be equal to 8 times 6 to the n minus first power. Let's see another example. Here we have a sub 3 is equal to 160, and a sub 8 is equal to negative 52.4288. Again, recalling that a sub n, since we have a geometric sequence, is a sub 1 by r to the n minus 1. We can write these as two equations. I'm going to use the second equation first. Negative 52.4288 is equal to a sub 1 by r to the 8 minus first power. And my second equation would be 160 is equal to a sub 1 by r to the 3 minus 1. Let's clean up those exponents a little bit. 8 minus 1 is 7. and 3 minus 1 is 2. And now I'll divide through term-wise. Alright, use a calculator here. Negative 52.4288, divide that by 160, is negative 0.32768. The a sub 1's reduce out, and I'd have r to the 5th. Solving for r by raising both sides to the 1/5 power. Alright, so let me take that answer, negative 0.32768, and raise that to the 1/5 power, negative 0.8. So r is equal to negative 0.8. Alright, take one of those original equations. I'll take that one, and now solve for a1, using the fact that r is negative 0.8. 160 is equal to a sub 1 by negative 0.8 square. So 160 is equal to a sub 1. Now, see, negative 0.8. Let's be careful here. In quantity, negative 0.8 raised to the 2nd power is 0.64. And divide through by the 0.64. 160 divided by 0.64 gives me 250. So 250 is equal to a sub 1, and I can write the model as a sub n is equal to 250 by negative 0.8 to the n minus 1.